So let's just do a couple more examples in Plotly. Let's just create a new data table. You can actually import, instead of typing in the data, you can import it. You can import it from Word or sticky notes. It can be just columns, numbers, or it can just be ordered pairs. Like I'm going to copy that and paste it in right here. Bang, it already knows to put the data in the right columns. It's using that as X and Y. You can always switch that up if you get it backwards. And again, I want to make a plot of this data. I already have this little window open over here, but I don't like line plots. I like scatter plots. And there it is. And we can see that this one is not x squared. It's definitely a power graph. It's going up to the right, so it's a power greater than 1. I'm going to fit the data. I am going to define my own function, and I'm going to try x. Oh heck, let's try x squared. I'm pretty sure it's not x squared. Yeah, see, that's curved too much. So let's try x to the 1.5. Remember, whole and half powers only in here. Run that fit. There it is. Add that result as an annotation, and don't forget to change x and y to actual meaningful variables. Let's do it one more time with some different data. Let's add another data table. You could always go back and write over one of your old data tables. I'm just going to make more and more tabs. Let's go back to my sticky notes and let's just import this table. Maybe I copied that from Word or Excel. So I copy and paste. It's okay that there's a blank spot. It doesn't worry about that. And again, I want to make a plot of this data. You could do a line plot, but I prefer scatter plots. You should probably do a scatter plot. And believe me, there's a million other functions here that we're skipping over. Hey, look at the shape of this one. It curves like this. That means it's a power less than 1. Which I'm going to close those, give it a little bigger picture. So again, I want to fit the data. That's this up here. Remember, there's a lot of other things to play with. You should become more familiar with this than me. I'm going to try, I could probably just try inverse, but I like doing that define your own function. So I'm going to write x to the negative 1.5. You see it was giving me an error value there until I fixed it. So it'll help you out if you're making mistakes. Like if you try to put a 5 in front of this, it'll say, wait, unknown operator, 5x, what's that? Oh, that would mean 5 times x. Alright, so let's run that fit. Nope. Let's edit the fit. Let's try negative 1. This is interesting. Let's try negative 2. No. Oh, you know what's happening? Let me move this out of the way. See, we're too low here. We're too low. We need to bring this value. And look, when you move over that data point, it tells you what it is. We need to move the 1 to a 5. How would you do that? Well, I kind of already gave it away. You need to put a 5 in front of this. 5. But again, you can't just type 5x. It says it doesn't know what to do with that, so you type 5 times x. Let's run that fit. Oh, pretty good. We got the first point matched. Now it's curved too much. How do I make it less curved? I take the power down. Down in the negative sense. Negative 1. You might have tried negative 1.5. But if you run that fit, there it is. And it's just about experimenting, learning to read the data, and listen to what it's telling you. Look at what it's telling you. I want to add that result to the annotation. I can close that little guy. Don't forget to change this, and change the x and the y value to something meaningful. Your data will probably never fall exactly on the line, so it becomes interpretation, right? All right. Good luck with all of it.